Hey everyone, welcome back to Anshul Codes. And today we are solving problem 3 of the NeetCode 250 series, valid anagram using C++. Let's first understand the problem in simple terms. So you are given two strings S and T. In the order of characters does not matter at all. If both strings match in terms of character count, return true, otherwise return false. And your task is to check whether both strings contain exactly the same characters with the same frequency. And now let's walk through an example to make this clear. In example 1, we can see the string S is race car and string T is car race. Rearrange the letters of race car. You can form car race. Most strings have R 2 times, A 2 times, C 2 times, and E 1 times. In both strings, you can check, right? So clearly both strings have identical character frequencies. That's why the output is true. Now let's go to the second example. The string S is jar and string T is gem. Here the character R in S is replaced by M. This R is replaced by this M. So the frequency does not match, and that's the reason the output is false. So now let's think, how can we solve this problem, right? So the brute force approach will be, we could sort both strings and then compare them and then check if they become equal after sorting, then they are the anagrams. But sorting will take order of n log n time, right? So this is not our optimized complexity, and we can actually do better than this. So the key idea is this: if two strings are anagrams, then even character must appear the same number of times in both strings. So instead of sorting, we can count frequencies. So the key intuition will be, we are using a data structure that is hash map, and we will store character counts. First, what we'll do, we will count how many times each character is appearing in string S. So our string S is race car, right? With using a hash map, we will say first R is 1 time, then A is 1 time, then C is also 1 time, then we'll check E is also 1 time, then again C. We will increase the count to be, then A, increase the count to be 2, and then at R, we will increase the count to be 2. That's how we will store the frequencies of string S in hash map, right? And then coming to the string T, that is car race. For string T, we will decrease those counts. Okay. So iterating through the for string T, we will decrease those counts of the frequency. For string T, the first element is C. So let me draw the hash map again. The frequencies were these one. For C, we will reduce this one to 1. For A, we will also reduce this to 1. For R, we will reduce this to 1. Again, for this R, we will reduce this to 0. For this A, we will reduce this to 0. For this C, we will reduce this to 0. And for this E, we will reduce this to 0. Now we can see that all the frequencies are 0. And that's how all counts will become 0. And just in case even one count is not 0, then they are not anagrams. For example, jar and gem, right? This was our S and this was our T. For this example, J, A, R. These were the frequencies. When we will go to the string T, we will reduce the frequencies. For this J, it will become 0. For A, it will become 0. For M, M does not exist. And then the frequency of R will remain 1. Okay. So this is not anagram. Now let's convert this idea into steps. So what will be our first step? We will check length. Just in case if length of S is not equals to length of T, then we will return false. This will save our time. Step 2, we will create a hash map. Then step 3, traverse string S. For each character, it will increase the count in the map. For step 4, what we will do, for each character, we will traverse string T and for each character we will decrease count, right? Here we will increase, and in final step we will go through the map, and if any value is not equals to 0, then we will return false, because they are not anagrams. Now let's go through the code line by line. We will start with the function definition. We will take input string s and string t. Then we will store their length using size s and size t. Next, what we'll do is check if the lengths are not equal, right? If they are different, we will immediately return false. This will save our time. Then in next section, what we will do is we will create an unordered map. This will store the frequency of each character. Now we loop through string s for each character s of I. We do mp s of I plus. This means we are increasing its count in the map. After that, in the second loop, we are iterating through the string t, and for each character in string t, we are decreasing the count. At this point, if both strings are anagrams, every character's count should be 0. And then we iterate through the map using an iterator, and if we find any value that is not 0, then we will return false. If the loop completes and all values are 0, we will return true. Now let's talk about the time complexity. Time complexity will be order of n because we are traversing string s once and string t once. And coming to the space complexity, this is order of 1. Even though we are using a hash map, but the number of possible characters is fixed, only 26 lowercase letters. So the space will be constant, because there will be no case that we can store more than 26 letters. Before ending, one quick insight: instead of unordered map, we could have also used an array of 26 alphabets, right? For even faster performance. But this approach is more general and easier to understand for beginners. So let's do a quick recap. We have done checklines at the starting. Then we have created a hash map. Then we have traversed the string s and increased the count, right? Then we have in next step traverse the string t and decreases the count. And then the next we have verified a check if there is any value 0. Is not equals to 0, then we have returned false. So this was the problem 3 of the NeetCode 250 series, and it is an important foundation problem for hash maps and frequency counting. Just in case if you found this explanation helpful, make sure to like the video, share it with your friends, and subscribe to the channel for more DSA content. Keep practicing, stay consistent, and I will see you in the next one. Till then, happy coding.